Hello, hello, hello. Welcome to Mofi Codes and Thursday stream. Today we're going to learn about containers, and myself is Mofi. We have,
I'm Nick. I'm a developer at IBM.
so today we're going to talk about Docker and we're going to learn basics of Docker and how we can get started on building containers. So, Nick, quickly before we get started, what do you know about Docker? Let's just get a level set of what we know about Docker so that we can start from a pretty much standard spot.
All right, so I know there's containers,
Okay.
and I know that I've used it in Kubernetes, and I had some sort of Docker file, and I put some code in there, and it built stuff for my Kubernetes, but I don't really know what Docker actually is or why I'm using it.
Okay.
Is it just this Docker file, or what else is going on?
Okay, so I think that's a good spot to start. A lot of people are coming to Docker because maybe their application needs Docker. They want to not just Docker, like they like the idea of containerizing their app that will just run anywhere. And a lot of people are also coming to Docker because they're trying to use Kubernetes, and Kubernetes kind of require you to use some sort of containerization. So that's a pretty good spot to be if you're trying to learn Docker. So let's quickly look at couple of the things about Docker. So I created like a handy-dandy slides to kind of go over quickly what Docker is and kind of the history behind where Docker came from. So I'm going to quickly go and present. So very first thing, why Docker? So you gave a pretty good answer with that. Like you were using Kubernetes and you had to everybody was like, oh, you have to use this image thing and containers. You have to just create Docker without knowing why Docker was created. But this is basically from the Docker website. That's what they said about why they created Docker, why Docker was needed. So it helps build and shape application faster. So when you're building application, when you were talking about the microservices world, in your application, it's divided up into, let's say, 20 different things. So each of them, like in a monolith, you can say I'm going to take 2 weeks to package, put everything nicely together, never going to touch it again. That kind of doesn't work anymore in a Kubernetes world or like a microservices world, because your application needs to get changed and modified over and over again. So you need a way to quickly package and ship that application. And containerization was the answer to that problem. But containerization itself wasn't easy enough for everyone kind of to use. That's why Docker was created. But the technology that Docker uses, none of them are crazy new in terms of. So if you look at this timeline we created, I kind of got down here. So chroot was created in 1979, back before even internet was created, just to be able to handle changing your root process, right? And that is kind of the idea of Docker. Docker, it runs as a process in the host OS. So with the root being changed to something else. So you're no longer using the root process on your host OS. You're using a different root. That technology existed in 1980s, right? Then in 2000, FreeBSD4, we had that idea of jail, kind of like inboxing a process, and that can talk to outside, or outside can talk to it. And you had technology like Solaris Zone, similar idea. Finally, in 2008, Linux container became a actual thing. You could create containers back in 2008 using programs programmatically create containers. But again, none of them were simple enough for anyone to just come in and build for their application. You had to build the containers using programs. Like the Docker file you wrote, for each program, you would write a separate program to create the container.
Okay.
So as much as you hated you writing a Docker file is actually much more simpler than creating separate application for each container you have to create. So with that, you have any question up to this part?
When was Docker?
Right. So Docker was first introduced actually in PyCon 2013.
Okay.
And the promise of Docker, again, none of this technology is crazy new per se, but the reason Docker became so successful is it gave us very simple API for developers like you and me to create containers. Before containers was being created only at big companies like Google, Red Hat, IBM, they had the manpower to put people to write a new application to create a new container for each application they were writing. That wasn't the case for the entire industry. But with Docker, you had a super simple API that anyone could use. The idea of images came in. We're going to talk about images versus containers in a second, but the idea of images came in, And you had the idea of image registry, just same as you have a code registry like GitHub or some version of anything old like that, Mercury or whatever you have. You had an idea of image registry. That means your image can be sent out to other people's image that are public and you want to use, you can take it. That made Docker become the behemoth it is right now in the tech industry. So you had another question, you don't know how containers actually work. So that is, I hope this gives you some idea how they work. So containers actually take two different parts. Number one is the Linux namespace, and number two, the Cgroups. So Linux namespace, again, we had that for a while. This is a way to isolate a process on like different parts. So number one is mount, exactly what volume it's using. Using that mount namespace, you can isolate a volume from the host processes and that process itself from the host processes from that process. So for example, anything that's running inside a Docker container, the host OS would not know what that file system is, and that file system will not have any control over the host file system. You have also things like IPC, that's the shared memory. You have PID, the process. If we're going to take a look at that in a second, but in our Docker container, the process it runs as root and number one process. So in our computer right now, let's say there is like thousands of processes running, and the number one process is something like systemd that ran to start the whole thing. But inside the Docker container, we'll have the number one process would be the Docker process that ran. But so we're kind of isolating that. So you can kind of think of this namespacing as kind of like a walls in a big hotel. A lot of people live in that hotel, but the room you are staying in, you have some walls there, and other people can't really just like look at what's going on inside. And you don't also, in the same time, you don't know exactly what happens in all the other places in the hotel. So you're kind of isolated in this small room. You can also have like different networks. So inside the Docker container, you can become localhost. You will be a separate user inside the Docker container. So all this way, you're basically isolating yourself as the process in Docker. And the Cgroups is basically the control group that you use to control how much resources you're going to give your container. How much RAM, how much CPU, things like that. Also, it controls what priority this particular process gets. Because again, you have to remember that even though you think like a container is like a thing that's running, it's still running as a process under the host. So if it have a different level of priority and the host is starving for resources, host will at some point start killing things. So using Cgroups, you can control what level of priority you give your particular container process. So basically those are like two major points. Namespace are like bounding boxes, and Cgroups are policy checks. You're giving policies, how much resource you get, how much priority you get, things like that. So, and you could still, to this day, using like Linux commands, build a container from scratch using Cgroups or namespaces. You probably don't want to, but you can. And that's how Docker technically works, but it just like wraps everything in a nice API so that it's easier for us to write a couple of CLI commands and it just works.
Gotcha.
Okay. All right, before I go to the next step, any questions in the previous steps?
I think it's a little fuzzy, but I think I'll understand it a little bit more once we start
okay.
going.
So before we can talk about what Docker is, I think it's important to know what Docker is not and what Docker is not meant to be. Number one, I think this is, and you had a question about this earlier as well, like what is the difference between Docker and VM? So Docker is not a virtualization platform. It's not here to replace, let's say, VMware or KVM or anything of that nature. When you talk about VMs in terms of application deployment, Docker and VM kind of like does the same thing for that particular scope of things, but VMs are so much more, right? VM can actually virtualize hardware, and for the process running on a VM, will think they're running on an actual hardware the VM is virtualizing. Docker doesn't deal with any of that. For the same reason, like you could run like a Windows VM on a Linux machine, but you wouldn't be able to run a Windows container on a Linux machine. You have Windows container, but they only work on Windows machine because in the end of the day, the process has to run on the host OS. It doesn't necessarily run on anything like, you could run, like I said, Docker container on a Mac OS because they use similar Linux processes. But you couldn't necessarily just run Docker container on like a Windows host. The Docker desktop for Windows, they actually spin up like a VM, and that's inside the VM you run Docker.
Okay.
And other thing is Docker, a lot of people also bring up the question that is Docker going to somehow replace virtualization? That's also, I don't think it's going to happen because most cloud providers you're going to use to run your Docker container scene is going to actually give you a VM to run Docker on. So VM is going to kind of rise up in the chain of abstraction rather than being replaced by Docker. So that's that. Number two, a lot of people think they're going to use Docker as some sort of like config managers, right? Just pass in all their configuration in Docker file and just like spin up. Technically, you could do that, but Docker's main benefit comes when you package your application and make it like a scalable way to create new copies of your application, not necessarily in that way. Docker is also not like a workload manager. It doesn't manage your workload in any way. It's not. So for that kind of work, you are looking at something like Consul, Mesos, or like Kubernetes. So Docker can spin up one container and one container down, but Docker doesn't necessarily know anything about how to spin up something if something dies. When you spin something up, something dies. Docker doesn't do anything about it. So it doesn't really manage workload that way. The fourth one is actually super interesting because I personally would use Docker as a development environment all the time because it makes it super easy to like spin up like a new database without having to change existing database you have. Spin up a new like a container that you can do some tinkering in. But for that kind of things, I think like a Vagrant VM works much better than a Docker because again, Docker containers are much more like you want to have a footprint on a Docker container much smaller than this.
All right, so I don't really know what Vagrant is, but I think the first time I actually did use Docker was whenever I was first starting out trying to use TensorFlow,
Okay.
and they give you the option to use a Docker thing to run TensorFlow. It had like it already installed in it. Or
Yeah,
something.
so basically they're giving you like a TensorFlow runtime in a Docker image, and again you could use it that way, but it's not necessarily like a scalable option. Like you are testing it out, but you're never going to use that in production. You know what I mean? So you can use like a similar idea, but you will package your entire application with TensorFlow in a Docker image, and someone just can spin that out. So the rule of thumb is if you're actually executing or like SHing into the Docker container and doing things in it, that's not gonna work out in the long run.
Okay.
So like that's kind of like what number 5, I think a lot of people think like when Docker became a thing, it's gonna somehow compete or replace cloud platforms as we know it. I don't think that's also true because yes, Docker gives some of the things cloud platforms are providing, but cloud platforms also provide so much more things other than just like abstraction of runtime, like security, policy checks, network, and all the other things that Docker itself cannot really provide. So this is the one I was talking about. I was talking about like what is the difference between Docker image and Docker container. So without looking at it, looking at the screen, you can look at the screen. What do you think Docker image and Docker container are?
Okay, so from what you were talking about earlier with like the image registry is kind of like the where you put your images. I feel like the container is probably like what holds the images, and like the image is like
it's close. So think of image as the blueprint of a container. So image kind of defines what a container should be, and container is the running instance of the image, the blueprint. If you are coming from like OOP terms, right? Like image is the class definition, whereas container would be the object instance.
Okay.
So for example, if you have a class car that defines what a car should be like, you can create like hundreds of car instances. Okay. But your car class stays the same.
Okay, and then another question, I guess, is what's the difference between an image and a Docker file? Are they the same thing, or like?
So this is where like things get a little tricky because the image is basically you can use a Docker file to most of the cases you will use a Docker file to create an image.
Okay.
So Docker file is kind of the template for creating a new image.
Okay.
Um,
So I guess it's like an image, kind of like just like sort of like the compiled form of like
you
a
can think
Docker
of
file.
that in that sense, yeah.
Like, does it take time to go from a Docker file to an image?
Yes.
Okay.
So this is another thing. I think this is going a little bit advanced, but that's fine. Docker uses what is called the union file system, and when you create an image, so in a Docker file, you're just putting text. I want this, I want that, I want this installed, I want that downloaded, and I want these commands to be run. That's just a text file. That is like
it needs to pull stuff in. Like,
exactly.
Yeah,
so when you have to build a Docker image using a Docker file, it will go ahead and download the base image, download all the things it needs to download, and create like a tarball of like union file system. All the things will be there.
Gotcha.
Every time you want to spin up a new container, it will just take that image and just put that in your host OS as like a new container and isolate that whatever it needs to do. And like you will then have that as a running process that you can access.
Gotcha.
Right? Okay. So you got, and again, this is, I'm going to say it like louder again. Docker is not virtualization. It's not exactly the same thing because Docker container, not just Docker, any container, no container is virtualization because containers run in the host OS as a process. So virtualization is a whole completely different thing. Virtualization creates a new host OS. So completely different thing. And last thing is like Docker CLI is the way to you would use access, like you would use to access Docker.
Okay.
Actually haven't checked if we, there you go. Boy. Okay. So I'm going to just leave it here. If someone wants to say hello. Okay. So next up, we're going to actually quickly jump to using Docker CLI in the terminal, and hopefully everybody can see it. Our screen is right here. Okay. So first things first, if I just if you have Docker installed, you can just type in Docker and it'll start working. If you don't have Docker installed, I actually uploaded a few videos, and let's see, youtube.com/c/moficodes. We recently got our channel to work. So I have like a playlist on Docker. This video is gonna also be uploaded in a second there, but you can just come here and find like how to install Docker for your particular OS. I have 3 videos here for Mac, Linux, and Windows. For Linux, I'm using Ubuntu, but you could choose to use some other Linux. That one you can like probably search online. But I have just 3 videos here that for your particular OS. So if you want to like install Docker, you can just follow along, or you can just find online somewhere to install Docker.
Right. So just out of me being pure lazy and I don't want to go back and watch these videos, can you briefly tell me how to set up Docker on the Mac?
Yeah, sure. So I think for Mac and Windows, installing Docker is actually much easier. Basically, they have binaries like Docker for Mac, and you basically just go to this website. You can just download this package from Docker Hub. Once you download and just click, it's gonna go through and do all the default installs. And once it's finished installing, you'll have something like this running. Docker desktop is running, and you can basically just use Docker on your terminal.
Okay,
and
so with Docker, there's like something kind of running in the background.
So what you have with Docker is something called the Docker engine and Docker client. And if I just did a Docker version, you would see that I have a client here. That's the one is my CLI tool and all other things. And also I have a Docker engine running. That is the one that handling all the Docker things I want to do. So that manages downloading images, building new images, and my other commands I want to run. And so you can see like I have both installed and I have all these things versions and set up, and I can also do Docker info. It'll give me more information what's going on. For example, right now I have 0 containers, 0 running, 0 pause, 0 stop, 0 images. So just like I deleted everything so that I can show you all the things for like Docker Hello from scratch. So you have all these things about information. You have runc as the default runtime and all these things. So Docker uses like something called the Docker runtime. That's how Docker can take any image downloaded from anywhere and then run it in the Docker engine. So we have Docker installed. If you don't have Docker installed already, you can find the videos and install them, or just like go to Docker Hub and download the Docker for Mac if you're using Mac. And also another thing to notice here, we're using the license of product is Community Edition. The Docker also have Enterprise Edition, but that costs money, and I'm broke.
What does the community edition give you versus?
So community edition is basically the free version of Docker. The enterprise edition has some extra checks. It has some security policies that you can enforce and things like that.
And then, so back to this little Docker icon thing.
Yeah.
So it says Docker is running.
Yeah.
So if that's not running, can you not use like the
So
CLI?
let's check it, right? If I quickly quit Docker desktop and Docker just stops running, if I do the Docker info again, you'll see it fails because the daemon is the thing that's running in the background. If it's not running, your Docker engine is not going to reply anything.
Right. So then what was I thinking?
But if I did Docker version, my Docker client is still running because client is a CLI tool that Docker is. But the other version, it couldn't connect to Docker daemon because it's not running.
Okay.
So let's just quickly restart Docker because, so you're going to just like give it takes a few seconds. It's going to just go ahead and wake up the daemon again.
And do you normally quit Docker, but like when you're not using it, or do you just leave it running?
I'm lazy. I don't want to like remember to run it over and over again. So I usually just have it running all the time. But I mean, Docker does use some resources in terms of RAM. I have 16 gigs of RAM in this machine. So usually it's not too big of a deal, but if I have Chrome, Slack, and Docker running, sometimes things get a little bit heavy. So
can you like start it back up with the CLI at all, or just?
Yeah, you can do a systemd service Docker start, but that's just like why? Like this. In Linux, that's how you do it. You just like systemd service start Docker, something like that. But yeah, Docker desktop started running, so I can do Docker version again, and I'll get back to this. My Docker engine is running, so everything is good. So let's get started, right? So Docker CLI, if I just type in Docker or Docker -help, it will show you all the things I could do on the CLI. So a couple of things in the beginning to remember is that they have a couple of options. So you're going to worry too much about them. These are pretty advanced, like TLS certificates and things like that. There are some management commands. Some of them are about creating network policy or like creating things like Docker Swarm. We didn't talk about it. Docker Swarm was a kind of contender for the same title as like Kubernetes, but Kubernetes just with their extra features and support, Kubernetes kind of became. So Docker Swarm is still available, you can use it, but most people don't. But like the commands, we're gonna mostly be interested in are the commands. So Docker has a ton of commands, right? It's a lot, but we're not gonna use all of them today. We used a couple already. We used the version command already, right? Just to see what Docker version we had. But we're gonna use a few today just to like get a feel for what Docker is and what Docker does. So very first command we're gonna use today is Docker run. And like any programming language you ever done, Hello World is like a big part of our community. So we're gonna use that again. We're gonna keep the tradition going. So I'm gonna run this command called Docker run Hello World, and this is actually a really cool command because it actually tells you what the command did once it's finished running. So first thing we're seeing, unable to find the hello world latest locally, this line right here. So, and then it just says pulling from something, library, blah, blah, then it comes in and just prints a bunch of things, right? And so it will actually tell you how this particular command worked. So first thing happened, it kind of contacted the Docker daemon, and Docker daemon looked at the local registry. If it had this image, it didn't. So it went and pulled the image from Docker Hub. And then using that image, it created a new container. And then whatever the output that container had, it just printed on my screen. That was the output, this particular output, this entire thing. Then it's telling me other things I could run and things like that.
Okay, so this running, what did you even run?
I ran Docker run Hello
World. So that just pulled up the Hello World image from Docker Hub?
Docker Hub, yeah. So Docker Hub is the image registry that we were talking about earlier, right? So remember we ran Docker info before, and we had, like we saw there was a 0, 0 everything. Right now you'll see I have one containers, but one of them is stopped. And we have one image, right? So if you want to see how many containers you have running, you can do something like a Docker PS. But if I do Docker PS right now, I'll see nothing is running because we know that it says right here that it's stopped. So if you want to see all containers, whether running or stopped, you could do Docker PS-A for all. And that will show you that one container ran. Another funny thing is that Docker does is every time you don't actually provide a name, it actually generates a random name by using adjective and I think the name of like famous scientists. So let's say I do the Docker run hello world one more time. Right? I just ran it. It just happened.
So now it should have found it from the local.
It found it from the local, but I think this printing is basically just like a static print from that particular image, so it'll just always print the same thing. And they're expecting you're running the hello world when you don't have an image. So this text is not going to change. But how many containers do you think we have now?
2.
Why do you have 2 containers? We just ran the same image again.
Because we ran a new one.
Yeah. So that is okay. So now if we look, we'll see you have 2 containers, 2 stopped, and if I do Docker ps-a, you'll see that again it got like a new name. It's now Peaceful Rubin, and again it ran 39 seconds ago, created 39 seconds ago, and exited 38 seconds ago. Just ran for 1 second. It just closed right away.
Nice.
So again, hello world is cool, but we want to see something a little bit more. Another image. Next, we're gonna see. So run in Docker is a very overloaded like tool. It pulls if it doesn't have the image already. It creates a container, then it starts the container. So there's 3 commands run automatically runs underneath. So if I did docker -- help again, we'll see all the 3 commands it's actually running. So it has the Docker pull command happening at the very beginning, pulls an image. So Docker run runs a conditional pull if it doesn't have pull it. Then it does create a new container. It does. We saw we had new containers created, and finally it does this. Starts one or more stop containers. So you can like basically start a new container.
Okay, I'm gonna write this down so I can remember. So it pulls.
Yeah.
Create.
Exactly. So create a new container and finally start the container.
Start.
So that's all 3 are kind of combined into run. But let's see how we can like then create like maybe do these commands individually.
Okay. So could we like start one of the stops containers?
We can start a stop container, but let's just pull a new container, right?
Okay.
So there is a container called BusyBox, and if you don't know what BusyBox is, so another thing, a lot of people will tell you that in Kubernetes world, you should never look inside your pods, right? You should never look inside, like exec into the pods to see what's happening inside. You can look at logs, but you should never do it. Like you look under the hood, because you're supposed to use other tools. Because if you're manually changing your pods in any way in Kubernetes, you're basically doing it wrong, right? So a lot of people, there is actually a pattern where people would put the BusyBox as a sidecar in your Kubernetes. Because BusyBox comes with a bunch of Kubernetes tool like CAD, like LS, and things like that, and Shell. Because you don't want to have your container that's running in Kubernetes to have like a shell, right? Because otherwise, if someone gets access to it, they can do all sorts of crazy things. Yeah. So, but you might want to, for testing purposes, you might want to like just jam a BusyBox as a sidecar. So the BusyBox has shell, and you can run curl to see what's going on in the network level, things like that. So that's BusyBox is like a Swiss Army knife of Linux commands. So you're gonna just pull this particular image, and again, we didn't have it. It just went on the library BusyBox. Just pull this image. Now if I do Docker, another command we didn't really show yet, but you're gonna see. It's called Docker images. So Docker images lists all the image I have in my system right now. So I have 2 images right now. One is BusyBox. One is Hello World. Another thing you will notice that BusyBox, although it's a Linux image, it's only 1.2 megabytes big, right? Oftentimes you will have images that are like pretty big, and this is not the case. I'll actually want to hide this. Turn hiding on, yeah, that way. Okay, so these are very small images. On the other hand, if I were to, let's say, Docker pull Ubuntu, again, that's gonna take a quick
26 megabytes.
Well, 26 megabytes zipped. So in total, it's like 64 megabytes. So they're both Linux, but one is 1/64 the size of the other.
Right.
Right. So let's test like a couple of things with what you can do with BusyBox. So we have an image for BusyBox, but we didn't do anything with the BusyBox image yet. So let's do Docker run. And also this time, instead of letting it create a random name for us, let's give it a name ourselves. So if you want to give a name, that like a flag is dash name, and what name do you want to give it? Naming is the hardest thing in industry.
It really is. Let's name it after this beautiful steel case.
Steel case. Okay, sure. Steel case. So that's gonna be the name of the image.
It's a pretty nice container.
I think so. I think it's just more. It just like oozes security. It's a steel case. I would have enjoyed a titanium case. Oh, Spencer is here. Hey, Spencer. So all right. So steel case is gonna give the name, and let's use the image BusyBox, and finally you're gonna give it like a command to run. So BusyBox again has all the Linux things like echo. We can do hello from steel case, and if I do that, hold on, Yeah, right. It's dash dash. I mean, I could do dash n or dash dash name. I just chose half of both. Okay, so we just see like the command just ran, and we just got the output. And the thing about BusyBox is BusyBox has no running process. So if you don't continuously run it, it will exit right after it finishes the command you gave it. So if I do a docker ps again, I will see nothing. But if I did docker,
so is Steelcase the name of the container, and then BusyBox is the image?
Yeah.
Okay.
Yeah. So BusyBox is the thing we downloaded. Right now you can see that the container ID is this. That's the ID that Docker gives it. So that's the reason we can actually give it any name we want.
Okay.
Right? Because Docker has a specific ID. It's a hash ID. It's actually a much longer name. It's just shortened here. Also, you can see what command it ran, when it started, when it exited right away. But we can do other things too with BusyBox. Let's say kind of like shell. We can connect a shell to BusyBox. I'm doing an air quote here because you're gonna see what it does. So Docker run. We're gonna do BusyBox again. We're gonna give it a new name. I'm gonna call it shell case.
What happens if you don't give it a new name? If you just keep calling it steel case? Does it use the old container somehow? Or
so it probably won't. It probably would actually fail because it couldn't. Let's just try it.
Yeah, let's do it.
BusyBox and echo and do a test, right? Yeah. So conflict. So steel case is already in use, so it will just fail. So ideally, since naming is not super crucial anyway, most people wouldn't even give it a name, and Docker will just choose a good name for it. But the command to look here is -it. I stands for interactive, T is for TTY, so we're connecting an interactive terminal into this BusyBox, and I just don't want to give it any command. Basically, if I do this, you're going to see that now you get the hash sign, you're basically inside a new machine. And the way I can prove it is basically if I do ls, it looks completely different than the like a system I was in. You can see things like which Python, it's actually not going to know anything because it doesn't have anything. It literally has no other tool other than just basic cat and other things. I can do an env. You'll see basically these are all the things it has. But on the other hand, if I exit out and do an env, right, that's my particular host OS env, which is a lot more. So if I do a docker ps-a again, you'll see that I have two BusyBox. And by default, BusyBox takes the command sh. So when I did it, it just started this particular command and gave it a name, Relaxed Einstein, which is the best name you could give to any particular container. So let's look at that again. Yeah, so it gave it the name Relaxed Einstein right here. So that happened. This is all great. So we can like attach. So how about if we can like attach, let's say, so how can we then start a stop container? That's, I think, something we can look at because all these containers are not gone. They're basically just stopped.
Right.
So let's try docker start, and I want to attach. So attach basically just attaches my output and input with this particular Docker container. And let's do confident or peaceful Rubin, right? Peaceful Rubin, then it will start the same container again and kill it right away because, again, this doesn't stay. And if I did it again, you will see that peaceful Rubin created 9 minutes ago and exited about 5 seconds ago, right? So This is all fine. And
Wait,
then,
so what does create do?
so create creates a new container. So when
Attach.
So if I were to just like Docker run peaceful Rubin, no, not run, start peaceful Rubin, it will actually just start it, and all the output we didn't get to see it.
Okay.
So with attach, we get to see the output. We actually basically.
So it's like headless with.
Right.
Okay.
So basically, with attach, we then get to pipe all the outputs that are coming into our terminal.
So by default, whenever you run Docker run, does it automatically attach?
Well, no. So
No.
basically, if it is a running process, it will. For example, like if it is like a web server, it will then like attach, then you'll keep listening all the things that's happening. But otherwise, if it's, for example, the hello world one, it just starts and kills right away. Well, everybody knows Spencer's MySQL password now. Cool. Okay, so all right, so let's then see another like couple of more things in Docker that is useful in terms of, let's say, an Nginx server. So again, we're gonna go through the same idea: Docker pull Nginx, and this is gonna go ahead because Nginx doesn't exist in our local system. It's gonna go off to the thing and it's gonna download Nginx into our system. Depending on what kind of internet speed you're dealing with, it might take longer. This is not too big. It's like about like 40 megs of download, so it will just finish downloading. But there are Docker images that could be like up to a gigabyte. And again, if you're building Docker images up to a gigabyte, stop. Don't do it. Find a way to make it smaller. There's a lot of ways to make it smaller. So if I do a Docker images, I'll see that Nginx is available now. And it's about 109 megabytes. It's still pretty big, but it's a whole server, so I can give them that. So let's start the Nginx server to see if it actually works. So the way you would basically start a server, I could just do Docker run Nginx. But the problem with that is Nginx server internally would actually open up the port 80, but I have from my local machine, again, remember I'm network isolated. So from my local machine, I have no way of accessing that port 80.
Right.
So the way we do it in Docker is basically by port forwarding. The way you port forward, you say port this, and I will say port, like let's say 8888 to port 80 of the container that's going to run. So the first one is going to be your port on your local machine, and the next one is going to be the port in the machine that's running it. So like the container port. Then we're going to say Nginx. And that's pretty much all I need right now. So if I do this, it's going to just spin up a new... so it's just running it. And another thing you're going to see, it didn't exist. Because I just said to run it, and it's going to hold on to it as long as the container runs. So I'm going to just keep it like this, and I'm going to actually go to my localhost 8888. So if I do that, you're going to see my Nginx server is running. Amazing. You can just like build up all sorts of application right now to the Nginx server, which is great. But again, this is not cool, any fun because this is just holding off our terminal right now. So if I just kill this and try to refresh the page, the Docker container is no longer running, so my Nginx server kind of dies. No fun. So the way you can solve this problem is by this command called -d, and -d basically just stands for detach. You're just running this as a background process.
With run, it was attached.
Yeah. So run
that's
was.
What I was asking.
Oh, sorry. So run was attached, but the thing is, my container itself doesn't have any running process, so it will just attach, but right away get out.
Right.
But this one, Nginx, is a running process. It just keeps running,
okay.
right? So I'm gonna do a -d to detach from the Nginx, and then once I do this, it's gonna just return me this big hash of giving me the ID of the Docker container running. But if I go back and refresh this thing now, you're gonna see that Nginx is running, but still it's just the Nginx default page, no fun. We want to just then somehow show our web page, right? And the web page I created. And in this folder, if you didn't notice, we had a index.html web page. And this is an amazing website that I have created. And like many of us who have started like doing web development have created this page. This page does this, right? It prints hello world to the screen. But now how can we, but this particular file is now in our local file system. How do you think we would go about getting that Nginx to run this file?
So I don't know much, but you could probably somehow attach this file into Docker.
So
or
one way you could do it,
a Docker file, and then like build off of the
right. So again, that's something you would do in a Docker file thing, right? So yeah, and I know I saw a couple of your Docker files. You have a couple of things where you're copying files from your local file system into the Docker image. So that definitely is a way to do it. But there is actually a much simpler way where, because when you run a website in Nginx, you don't necessarily expect that file to change, right? So even if you change the file, that's the file you control. So one thing we can do in Docker is called volume mount. We can attach a volume from my local file system into the Docker file system. So we're going to try doing that right now. So I have this to be copied. Actually, this is a pretty long command, so I just copied it. Oh boy.
I want you to write it from scratch. Okay?
Yeah.
That's how we learn.
So this is the command. So basically, it says docker run -v. -v is the flag for attaching volume. You give the path to this entire file up to the folder. And in Nginx, the folder that Nginx serves is this folder. So that is something you have to kind of like know.
Right.
And you're giving it the permission to read. It's just giving it a read permission. It doesn't need to write.
RO?
It's just like permission to read in a Linux system. And again, the same thing we did before, port, but now we're listening to port 8080, right? And I'll just run this. And again, remember the -d, that's why it became detached. So what do you think is going to happen to this particular thing?
It'll become our nice little hello world text.
Well, no, because that's a different port. We actually ran this on 8080.
Okay.
Not 8808, 8080. And if I go this, hello world.
You tricked me.
I know. But the reason I ran it on 8080 because if I actually try to run this on 8080, the port is being used and it'll just yell at me. Error response, blah, blah, blah. But the thing you'll notice here that the port 80 I could use over and over again because each container has its own port 80.
Right.
But my host has only one port 8088. So if I just quickly do a Docker PS now, you'll see that I have a bunch of things still running. Nginx, and Nginx has a built-in command when Nginx runs. So we're gonna see the next command in Docker. Next two commands. Number one is docker stop. And when you have to stop a Docker container, all you need is the Docker ID, container ID. And Docker is actually pretty smart. You don't have to actually type in the whole thing. As long as you can type in the unique part of it, Docker daemon Docker CLI tool would know what to fill in. So if I just were to do 13, right, I'd feel like that is unique enough. I can just press enter, and it just killed that process. And to prove it did it, I can do Docker PS that just killed it.
What happens if it's not unique enough?
If it's not unique, actually gonna give an error response from the daemon because it couldn't decide which one to kill. So Docker stopped it. So if I do Docker PS-A, you will see that it's just stopped. It just stopped this minute ago. It's still running. This one is stopped. 13. It's right here. That means we just like kind of stop is kind of like pausing the process. The process is still available. You can just go back to it whenever you want. But there's another command called docker kill. And docker kill, we're gonna kill the process that started with 63 or I think 90. Yeah, 90 is the process we're gonna kill. So 90. If I kill this process and if I do a docker ps dash, docker ps is gone. Docker ps-a it's still here. So what do you think the difference between stop and kill is?
I feel like kill is just completely killing stuff.
Yeah, so...
And stop is probably more graceful somehow.
Yeah, I mean, I personally didn't see too much difference between kill and stop. They do the same thing. They just like go to the pause state and restart them again, even if you kill it. So use whatever you want. Mostly probably we'll just use stop for the most part. Not kill just sounds more like aggressive than it is, right? So like
where is stop on?
So stop is with S. So stop one or more running containers, and kill one or more running containers. That's basically the same thing. But kill just sounds more aggressive to me. I just end up using stop. There probably is a difference. We can look it up later, but
Okay.
I didn't see any particular difference when I used it. So I just use stop for the most part. So docker ps-a. We have a bunch of this like stopped container just like hanging around here. So there are a couple of ways like we can get rid of these containers. Because they're stopped, we don't no longer want to go back to it. So we should always like kind of clean up after ourselves. So docker container, hold on, rm. Then let's say I remove the 63, 638. So I just remove this, docker ps-a. You'll see that that particular container is no longer there. But again, removing one by one is going to be like too much hassle. So if you know that none of the containers that are stopped, you need them anymore, what I can come and do is docker container prune. Prune is basically just like pruning, getting rid of extra things. So if I do that, it's going to ask me, this will actually remove all stopped containers. And if we want it, yes, I do want it, that will go ahead and clear out all my stopped containers. So docker ps-a, there's nothing. Docker images, I have still a bunch of images left. If you want to delete an image, same idea. The command is docker rmi to remove an image. You can either give an image ID or a repository name to remove an image. But if you also want to like get rid of every single thing in Docker, just clean up the entire system for you. The command is docker system prune -a for all. I have to prune all my systems. If I do that, it's gonna stop. So you can actually skip the stop container with just system command. Stop container, networks, images, or build cache. It just gets rid of everything. And I'm gonna say yes, please do it. And it's gonna like give back some of my space that I was using. So right now, if I do a docker info again, I'll see that I have basically nothing running. And I think this gives you a pretty good solid start to all the Docker commands we have. Next time we do Docker, we're going to start learning about how we can build our own Docker files from scratch.
Okay.
That's the one we're going to do. So with just what we talked about today, do you have any questions?
I guess my only question is, like how much space and like memory and stuff gets used like when you're making a Docker container? Like, does it like fill your computer or like?
It doesn't fill your computer per se, but let's say like right now, if I look at my process, and a lot of people can't really see it because of the image, our image is blocking it. But hold on, maybe activity monitor would be good. So if I look at memory, and you'll actually see that you should be able to see Docker. So right now, Docker is the most memory intensive task in my entire system. It's about 3.3 gigs of memory. And again, if you have Slack and Chrome running, oh, by the way, happy birthday, Slack. It's Slack's anniversary. So we make fun of Slack a lot, but Slack is super useful for us to communicate. And we at IBM use Slack pretty heavily. Every time I go to any Slack conference, it's funny because we are not necessarily a sponsor, but our name is like such big because we're like their biggest customer with like 400,000 licenses. It's insane. But yeah, so Slack, Chrome, and Docker, if you have all three running, you're going to see a lot of heavy use of memory. But right now, I have no Docker images, no containers running, but just the Docker daemon itself is using about 3 gigs of space, RAM space in my system. So,
what about disk space?
Disk space is exactly how many images you have downloaded. Right now, I'm using no, because for example, when I prune my system, I got back about 174 megabytes of space. If you remember, I had a 100 megabyte sized.
All right, because I guess whenever you create an image,
that uses space as well.
Right.
That mounts the space, but the downloaded image I think is the biggest space user.
Okay.
If you have like 10 like gigabytes of images each, they're gonna take up 10 gigabytes of space.
Right.
But mounting them also takes some space. But those come back pretty easily. When they stop, they're no longer mounted, so that come back pretty fast. But like again, we got back 174. Yesterday when I was cleaning up my system for today, I think I got back like 17 gigabytes of space back, which was insane. So I have this machine right now. I have here is like 500 gig, 500 gig hard drive and 16 gigs of RAM. I never really felt that I was like being blocked from using Docker or while I was doing other things. But if you have like a, let's say 8 gig RAM machine, you are also running, let's say Docker, Kubernetes in Docker, you're using Chrome, you're recording your screen. With all that, you're going to start seeing some lag in your system if you're using Docker.
Okay.
Yeah, so with that, I think it's a good spot to stop. We still reach 50 minutes, although I said I'm gonna try to keep it below 40, but it's hard to keep track of time when you're having fun, right? So yeah, with that, this video is gonna get uploaded to YouTube in a second. In our channel, I'm gonna post the link as well with the video, with the other videos you can download to install Docker in your system. We're gonna have more videos coming soon. Next week, Nick is gonna talk us more about AI. So if you're interested in that, do check us out. Yeah, so find our channel on YouTube as well. It's also Moficodes. The short URL is youtube.com/c/Moficodes. So do find us there. And thank you for joining us in this beautiful Thursday. And hope to see you next time.